Someone's first. I'm live. How's it going? This is Mr. Stark, and I'm going to be talking about math. Some math Q&A going on this Thursday. Someone's first. I'm live. How's it going? This is Mr. Stark, and I'm going to be talking about math. Some math Q&A going on this Thursday. So the second week of school for Texas students, and I think there's even like some Midwest kids who haven't even started school. It's pretty crazy. So I don't know if they're joining. They're getting a head start, man. I don't know why they would be joining. But I want to first start out with a few thoughts about the first week of, I don't know, a few of my classes that I taught. So calculus AB specifically, pre-calculus, and advanced algebra 2. So I'm going to start with those things, just a few like big picture things to get you going. And if you're watching this and you're a student of mine last year and we had to say goodbye, I'm so glad you joined. So while I do this, I would like you to prepare your question, and I'll be looking at the live chat to see what's going on, and I could answer your questions live. And then you could stand for a little longer to see some other questions, or sign off and continue with your life. Okay, so for Advanced Algebra 2 students, for students who are going into that class, they had some summer work to do, to watch some videos and take some notes in a booklet and get ready for that advanced class. So if those students are on here and they're asking questions, that's the prerequisite that you finish that. So, of course, you could ask questions about the first week of school, no problem. But main things are like graphing calculator basics, like how to use some of the main functionalities, how to get fractions, how to convert fractions, how to reset your calculator, how to set the zoom in window, stuff like that. So that's super helpful. And then the general idea that you're working with linear functions, and the focus is on the point slope formula. And then working with lists, so like stat edit versus second table. Okay, so that's advanced algebra 2. What? All right. Next thing, calculus. So I have a current series that's going on. I'm creating videos every few days. The first one was about a week ago, and then the second one a few days ago, the third one yesterday. So I'm working on the fourth one, which is lesson 2B, and that is pretty much in line with a regular calculus AB class, whether you are in Texas, New Hampshire, or, you know, like a state that's outside of the US, like Hawaii. That's in the US though. 51st state. Just kidding. Is it the 49th or the 50th? Okay, so in calculus, the first unit is challenging. It's focused on limits and continuity. So not the most pleasant way to start, but the next unit is very pleasant. Well, we just got to get some of this basic stuff out of the way. But if you're one of my students, you had some good experience with limits. But if you are working through the first lessons in limits, still trying to figure that out, you might be trying to wrap your brain around what is a limit. So I encourage you to lean in on that idea and notice the difference between, you know, the practical approach to limits versus the types of methods that you can use and the approaches. So methods meaning what are the algebraic methods, and then approaches would be like numerical, graphical, algebraic. So I have some thoughts about that. If students had questions, there are some specific pages and questions that are in my materials that I know questions come up occasionally, and I have some specific thoughts on those. And then finally, pre-calc, functions and graphs. I have the entire series, the entire unit, which is called a playlist on YouTube. On my channel right now, there are 14 videos. The last one is kind of funny. But those are available now for students to work through, just in case their teacher might not communicate everything perfectly. So I'm ready for a question. I'm just hanging out here in my studio. And I am happy to answer a question. And we're live, folks. We're live from Austin, Texas. Hello, Flash Cry. How's it going? This is Mr. Stark here. Just ready, just ready. I'm ready. Oh man, you're welcome. You're welcome. But wait, who's Flash Cry? Is that Roland? All right, all right. Oh man, I can't wait till the moment where I'm got all the gear ready to go and I'll be drawing stuff on the screen, going bonkers. I was thinking about just doing like just like a 30-minute live video of me just doing math problems. Just a normal everyday day in the life of Stark. Okay, I'm going to start with my first thing that I have prepared for anybody who watches this now or later. And this is in this booklet that I made. And one of the first things it talks about is doing a conversion from fractions to decimals. But there's this other thing that I want to talk about as far as fractions. Whenever you're entering a function, like a rational function, in the calculator, boop, boop, boop. I'm telling you, this is super helpful. It avoids so many issues. So I'm in my mode, and I'm just in a regular function mode. And boom, all right, so I want to enter a function in. Alpha, y equals, enter. We got an option to enter a numerator and a denominator. Super helpful. Avoid using parentheses, all that stuff. Alpha, y equals, and you could enter your function. And that could be a combination of a trig function and a linear function, or whatever. Got lots more tips like that. So while I'm here, I'm going to enter this function 1 over x. Next tip, I got this function in here, right? 1 over x. All right, I'll just go to the right here. Boom. 1 over x. Common reciprocal function, pretty famous. Is this backwards? Shoot. Anyways, I press graph. This will work either way. I think it could be flipped. Oh, I got to do zoom 6. There you go. That's a tip. Zoom 6 to get that function graphed properly. There we go. Okay, so notice we got this thing that looks like the function ends up here at the top, but it totally does not. It's just that there are only so many pixels on this calculator that seems like it's from 1984, but it's not. We'll just call it TI-84. Actually, maybe the software originally was from 1984. Anyways, so entering the fraction in like that is good. And then seeing that that function is not officially ending is just something to keep aware of. That our technology sometimes limits us to do the fancy math. That's that. So along with that, last little graphing calculator tip for now is There are two main things that look really similar on the T84. Second table, it takes us to the table. So we have a table of values for x and y. But there's also a list option on the calculator. So if I press Stab, Enter, we have lists. List 1, 2, 3, 4, 5. And those two things are totally different, even though they look very similar. So a list helps you analyze data so you could get like a model for it and do a regression analysis. And the table, second graph, boom, helps us see the actual table of values. Just ready for some math questions. It's like free tutoring that comes outside of your computer. Bum bum. Next thing. Okay, I think calculus. I want to talk about some calculus right now. There are properties in calculus. There are algebraic properties that are usually found in like the first chapter. Well, the first chapter might be a prerequisites chapter for calculus, and then the chapter after that, limits and continuity. So the Finney text is the one that I've used the most over the past 10 years, but there's also Sullivan and some other texts. But usually the first list of properties are the regular algebraic properties, such that when x approaches a real number, then you have these properties that will hold true. So if these certain prerequisites for, well, let's call them conditions for the properties, are true, as in if the limit of two separate functions are real, then all these properties hold true. And that is for limits as x goes to a finite number, a real number, okay? But there's a second list of properties, and usually that's the second list of properties in that specific chapter. If you have a question about this, boom, let me know. Pose it, comment it, send it to me some other way. But that second list of properties is the list of properties as x approaches infinity or negative infinity. So those two sets of properties, they really highlight the fact that limits act a lot like real numbers. You know, if you take two numbers and you add them, then you could just add them together and you'll get their result. And then the same idea goes, you know, add, subtract, multiply, divide, and powers as well. So I have two separate videos about that. 1A lists the first set of properties, and then 2A lists the second set of properties. Okay. Hello, 4 people. How come I can't see who exactly is in here? Oh, right. I have to wait till you comment. That's fine. Ah, yes. Okay, so I'm ready for any questions, but yeah, can't wait to that day where I'm just going to do math. I can't go right through the booklet that I created. That would be wrong, wouldn't it? I think that would be wrong, because then all the kids would have the answers. The next thing I want to say, this is especially for students who are working through a booklet like this in calculus. Calc AB. There's a question on page 11. This is the end of topic 1. Page 11, number 16. I remember back in high school, I was in pre-calculus as a senior, and my teacher would always select, I don't know, he'd give us like 8 or 10 questions to do. The first 4 or 5 questions are like ones, oh yeah, that was just like the example, basically redoing the example, this is great. And then the next few questions are, you know, level up, maybe there's a few more fractions or decimals, or it has you use your calculator. But back then, it was like the TI-85, which was weird, because it seems newer. But then the last question was always like the hardest question, and this is me trying to do this question at like 9:30 at night, which seemed late for me at the time, but as a teacher I realized sometimes students are hanging out until like 11 or 12 at night. Oh my gosh! But the last question in this particular topic is really, really good. So I encourage you to work through it if you're in calculus right now. It is the best way that you could confirm that you know what the heck is going on in topic 1. It's not a question that covers everything in the first topic, by no means, but it's hitting up like the whole instantaneous rate of change concept in the first topic. So check it out. Even if it's not assigned, I encourage you to work through it and make sure you can get the answer algebraically based on the first example. Oh man, I might be done quicker than I thought here. So, I just have a few more things, but if you have a thing, your question is more important than what I'm about to say, because I have been spending lots of time making some videos to tell you what's going on. What was? Oh, that question? Question number 16. So, we got 9 people here. Thanks for coming. Glad you're here. I don't know. Where are you? Maybe you are on your way home from school. You got picked up late. Or maybe you have volleyball practice tonight and you're like, oh my gosh. What? Oh yeah, I expected the quiz Friday. That's why I'm on here right now. I'm ready to prep you for your first calculus quiz, even though that's what I did back in May as well. But, all right, but I'm going to come back to that in a second. I'll say some things about pre-calc for some students who might be in Advanced Algebra 2 or pre-calc right now. I know some of you were in that. So I'll say this. Let me go to pre-calc's first unit. So like I said, pre-calc functions and graphs, all 14 videos are available right now, and you can go through those and like fill in the blanks of like what you got from class and stuff like that. But in the functions and graphs unit, it starts with kind of a lot of stuff that seems mishmashy at first, and it's hard to get some traction at the beginning. So I'll just say that in the first few topics, really the main idea is understanding that there are 3 main approaches to just doing math all the time. And that's a numeric approach, where you're playing with numbers, you're plugging in numbers, you're calculating stuff on the calculator, whatever. And then there's the like algebraic or formulaic approach to math. So that's something where you actually have a formula you're working with, or you're doing some algebraic stuff, like some techniques. Common denominator is an algebraic thing, or solving an equation. And then finally, a graphical approach. And I mentioned graphical last because it's usually a lot easier for us humans to like go straight to a calculator to see something or to try to visualize something. And if we could try to understand it before we visualize it, it's super helpful because then the visual just confirms what we already know. So then in the rest of topic 1, it's like some quadratic formula stuff, and all of a sudden you have questions that may have you do like simplifying roots, which is kind of tricky. So I hope this is useful to somebody. And then topic 2, you get into a bunch of like properties for functions. So it's 4 main sections for functions that lead into calculus concepts in calculus. Okay, so I could come up with some stuff to help you with your quiz tomorrow if you're a calculus student and you just need to hear maybe something again, or you want to hear somebody who's made 2 of those quizzes every year for the past 10 years. Oh, I wonder if I have my quiz in the back of my book. Oh man, I sure do. Oh, there's the test. Oh yeah, that's a good quiz right there. Okay, I got my quiz. I'm not going to show you. But here's my first tip for the first calculus quiz. You should be able to find the limit of a function just by plugging in a number. That's officially called substitution. So you should be able to, excuse me, you should be able to have any random function, could have a fraction or not a fraction, and if the limit as x approaches 0 or 5 or 3 or -2, what's up? Welcome, welcome. Just talking about calculus. So you should be able to plug in a number and get a real answer. Now, the trick comes that if you plug in a number and you get something, yes, I can. If you plug in something and you get 16, that's the one I mentioned, I think, right? Cool. So if you plug in a number in and you get like something divided by 0 or 0 divided by 0, you know you either did something wrong or you need to try another approach. So you need to use the calculator to look at the table, and if a calculator is not allowed, that gives you a little bit of a hint that you should be able to do it without a calculator. Actually, let me throw a few more tips here just in case that was all someone needed. Again, you should be able to find the limit of a function and then just be able to do it algebraically. So be able to like factor or find a common denominator or something like that. So those are 5 techniques that are in lesson 1. I think it's lesson 1B. Yeah, 1B. I did a quick little summary at the end of lesson 1B, I think. No, I mentioned it at 2A, the last video, about the difference between the properties, the techniques, and the approaches. You should be able to look at a table, plug in some numbers, and find out what the limit of a function is. You should be able to find the limit as x approaches infinity of a function. So in other words, what's that limit or what's the asymptote? And then depending on where you're at, like you might have to find the vertical asymptote or an end behavior model, but that's 2B. Oh, here we go. I'm ready for this. I'm ready to do number 16. And I'll write this down for those of you who don't know what the heck I'm talking about. You know, like let's say you're in college and you just want to like see some calculus for fun and do that. That's great. And okay, I need a little confirmation though. If I show you this, I actually don't know if it's backwards. Is this backwards? Or forwards? I don't know. Yes. Oh, good. Okay. Sweet. So here's the first question. Question number 16. It's y equals 19t squared, which is basically representing like the distance that an object falls. So it doesn't have a negative sign, so it's not representing the position of an object. And so the first question is just find the average speed for time equals 0 to time equals 9. So the question officially says during the first 9 seconds of the fall. Not the fall in Genesis, just the fall on planet X. So pretty low key. But I'm interpreting that as time equals 0 to time equals 9, because time equals 0 is like the beginning of time, which reminds me of the fall. So that is a fairly simple question, and I'll do that in just a moment. But question B is like the more valuable question. We want to find the speed at time equals 9. So part B is like the calculus question, and part A is the pre-calculus, the algebra question. Question A could be answered before Isaac Newton and Gottfried Leibniz, and question B needed the work of calculus to do that. All right, so just to answer question A, like really quickly, we would just plug in 9. So we would find slope between 2 points. And so we would do 19 times 9 squared minus 0 over 9 minus 0. So whatever 19 times 9 squared is, we're not doing 19 times 9 first. We're squaring 9. So 81 times 19 divided by 9. 81 times 19 divided by 9 is the same as 9 times 19. So whatever that number is, that is the average speed of the object on this planet. So this planet has a different gravity than we do on Earth. Okay. Again, I'm not going to say easy, because I feel like nothing in life is easy anymore. Part B. It says find the speed at time equals 9. When a question says find the speed at, the word at is used, that means at the instant, at a moment. And again, that's something that requires calculus. So we're using the limit of the difference quotient. So don't be confused by just the fact that it says speed. We're not doing any sort of physics stuff here, even though it's related. We are saying, okay, what we're actually doing is we're finding the instantaneous speed. So now that we know that, we could look back in our notes that we got from like our first lesson, which goes back to like pre-calc in May and what you're doing, learning the limit of the difference quotient at the very first time. So here it goes. I'm going to take the limit as h approaches 0 of 19 times t plus h squared minus 19t squared. All over h. Such a great question to ask. And now, I don't know, do I go all the way with this question? Well, I won't officially do every single detailed step, but at this point, anybody who's in the first week of calculus should be able to do this without too much difficulty, because now, like without the limit, if you just cover up that limit for now, without that, all this is screaming at you is saying, just like do some math, do some algebra. Distribute that t plus h to itself. Okay, so I still have a limit at the beginning. And I'm going to skip a step here. We got 19t squared. We got 2th from the inner and outer of a foiling. So we have a 38th plus 19h squared. I ran out of space, 19t squared. Okay. So if you're still with me, there's the next step. And I'm confident that you could have found that. Notice my little 19t squared that I had to subtract there. That's this 19t squared. Okay, so what happens is that first one and the last one, subtract out, you know that. Right. And then we could just, the rest of this we could simplify. So I think what's cool here is that when we look at this, we could still, like, we could plug in 0 for h at any point. We could say, I want to see what happens if I do that. You know, I have plenty of space if I'm doing this in my booklet. But what we would notice is that we would get 0 plus 0 divided by 0. So that posed in the video in a lesson is basically saying, hey, this is messed up, because like if we were to find the speed before and after 9, we would actually get the speed for this object. But then you get undefined, which doesn't actually make sense. So calculus was basically invented so they could answer this question, what's happening at that time value. So I'm going to factor on the h. And then I'll ask you what to do next. What do we do next? I think what I appreciate about my time as a teacher is how I was able to train with awkward silence. It's not completely silent right now because my AC just kicked on, but sitting in that moment, right? Just waiting. We still have a limit. And I'm not officially going to go all the way with this, but we have the limit of a sum. And since the sum is not commutative, there's a property. It doesn't have a property that allows you to just leave off the parentheses in this case. So we have to use parentheses for this last limit, because we don't want any ambiguity as to, are we taking the limit of just 38t or both 38t and 19h? Okay, that's number 16. Now we could plug in that 0, which is basically called substitution, and we get a real number, well, a real expression, and then we could plug in time equals 9 to get the official answer. So let's say we plugged in 0, you know, that got rid of this bit. We plugged in a negative number. If the question asks for speed and our expression that we got is negative, what must we do? Question about your question? IH? Okay, okay. You got it. Yep. And I hope that confirms the answer. Like, I hope that's the same. Oh, my question was, do you have a question about your question? Did I answer your question? Okay, one more time. There it is, number 16. There's a function that describes the gravity or the position of an object, basically, on the planet. You're welcome. If you have another one, let me know. But this is it. And basically, if any function that has a squared unit, if it's a quadratic function with just one term, then this question is going to look the same every time. So if you could find a pattern between this expression and this right here, then you'll be able to know the answer to this question before you even do all the work related to it. But that's not an invitation to not do the work, because that's what you do in this first unit. So I guess to be specific about that, in this first unit of study, the way that you're finding the instantaneous speed of a position function is you're using the limit of the difference quotient, which is this, the limit of the difference quotient, and you're showing all those steps. But you only do that for the first unit. So once you're done with the second unit, you'll kind of wrap it up with some of those concepts. And then in derivatives, you will find some shortcuts to use for quadratic functions, polynomials in general, and then you'll start to hit up like trig functions, which is kind of cool. Trig functions are the best. Miss you guys if I had you in Advanced Algebra 2. Miss you especially. There's a difference between missing students and missing the work and missing waking up at 5:30 every day. It's crazy. Topic 2, number 15. You were assigned that question? I guess that is kind of a good question, actually. So, okay. We got time. All right, question number 15. So this is a question where, actually, this reminds me of like my first few years when I was using a question like this. Sometimes I didn't assign this question, and I gave a question on the quiz that was like this question without knowing it. So, okay, so the first part of the question is basically you're finding the domain and the range of a function. And so that's, I don't know, it's kind of basic. It's usually not like a quiz question because it's a pre-calc concept. And then part B, where does the limit as x approaches c of f of x exist? And that's a pretty good question because you're kind of verifying stuff that was in the beginning of topic 2, one-sided limits. Yeah. Oh, and then part C, at what point does only the left hand? Okay, so only left hand limit exists. And then right hand. Okay, so I'm going to just jot down this function. So this is officially called a piecewise function. Anytime you have a function that's broken up into pieces, called a piecewise function. But sometimes it doesn't make us feel wise. Okay, so here it is. And I'll say a few nuggets of info before I actually start to do part B. Unless, Isaac, you have like a specific preference for part A, B, C, D. I kind of feel like actually it's weird because it asks for the graph of f of x. That's really the best part of the question, and I'll get to that. But yeah, B is like a good starter point, and then once you get C, you could get D. So I guess I just want to say like that all of these stipulations here, these conditions, is that this is basically a semicircle. You know, it looks like the Pythagorean theorem, x squared plus y squared equals 64, but y is here, so it's basically solved for y. So it's like a semicircle with radius 8, and it starts at 0 and goes up to 8, but not including 8. But it could include 8 if we wanted it to. Okay, then so notice that if we do include 8, if you plug in 8, you get 64 minus 64, which is 0. So I'm just going to write that down. So f of 8 for the first part of the piecewise function is 8. So I've never actually done that before, but that is, I think, super helpful to do. So then notice the second part, it says that f of x equals 8 from 8 to 16. So if you think about like what does it mean for y to be equal to 8 or a function to be equal to 8 from 8 to 16? That means that it's a constant function. So it means that if you plug in 8, you're just going to get 8 because there's nothing to plug in for. So it's 8. Plug in 9, you get 8. Plug in 10, you get 8. 11, 8. F of 12 is 8. F of 13 is 8. All the way up to 16 is 8. So 8, 8, 8 all the way across. So if we were to draw this function, first it'd be a semicircle, then it'd be a constant function. Boom, last one, 16. If you plug in 16, you get 16. Okay, so this is a numerical approach to working with this function. So I just want to point out that what happens with this function is it jumps from 0 to 8, and then it's continuous. So it jumps from like a height of 0 to 8, and it goes from 0 for x to 8. So it's a little bit confusing. So then f of, well, the actual function is 8 all the way up to x equals 16. And then it jumps again. So these are the y values. It's jumping from 0 to 8 to 16. So we're kind of expecting there to be like issues at those points. So when does the limit as x approaches c of f of x exist? All right, I'm going to do a new page here. But if I should focus on one part of this question, let me know. Otherwise, I'm just going to point out two things. Okay, so the first point we're going to actually, well, the first set of points is x approaches, like, let's say 8. So if we're taking the two-sided limit, because there's no plus or minus superscript as x approaches 8, that means we have to consider the left side, which is 0, and the right side. Which is 8. Oops. So, because those two numbers are different, 8 and 0, the limit as x approaches 8, the two-sided limit, does not exist. That's a big idea. That's a super big idea. That's a super duper big idea. That if the left-sided limit, the left-hand limit, and the right-hand limit at a point, call it 2 or 5 or 8 or -3, those two limits, one-sided limits, are not equal to each other, then the two-sided limit does not exist. That means that there are 2 points, kind of like 3 actually. There are 2 points where the limit does not exist. X equals 8 and 16. Because we already talked about that. Oops. So just that numerical analysis that we did at the beginning helps us understand this symbolic analysis, which is basically an algebraic approach. And if we wanted to, we could graph this. That's actually too much work to enter the different parts. But if anybody's interested in that, I can actually do like a little, I haven't done a YouTube short yet. Actually do a YouTube short. Maybe TikTok one day, I haven't decided. But I do a little short on that, like how to enter it in the calculator and then see it pretty quickly. But usually for these types of questions, we don't have the calculator because it takes too long. So point being here, 0 is an issue too, because that's when the function actually begins. There's nothing to the left of 0. So if you put a bracket for that or a parenthesis for the left side of 0, that would, in my opinion, it doesn't actually matter because we're not discussing that. So yeah. So basically, here's what I think the answer should be. Was 8 okay? No, 8 was not okay. That's what I think the answer is. 0 can't be included because there's nothing to the left of 0. 8 is not included because the two one-sided limits don't exist. Sorry, they're not equal to each other at 8. And then everything between 8 and 16 works, but exclusive of 16. Okay, so that leads to like part C and D, and you could find out where the left hand and the right hand limit exists. But I want to just show real quickly like how you could actually sketch a picture of this. So yeah. Okay, so I'm just going to try to do that fairly quickly. So the highest that the graph goes on the x-axis, farthest to the right, is 16, and the highest that it goes on the y-axis is 16 as well, which again like makes this kind of confusing, but also fairly pleasant in the same manner. So that's what my graph looks like. So I'm just going to sketch this semicircle from 0 to 8 first. which means it goes to a height of 8. It reaches its peak at 4. Oh yeah. I'm going to use orange for the graph. 0 to 8. Okay, boom. I got that. But then at x equals 8, there's an open hole. So I was like super obvious about that, even though I almost forgot about it. And then from 8 to 16, so 8 is defined. So that's just the beginning part of my constant line. So a constant is just a horizontal line. And then because there's that open inequality for 16, then we have an open hole there. Well, bam. And then the last part of the piecewise function is that when you plug in 16 for x, you get 16 for y. So then we'll have this random closed hole circle on the top right. So these are things that, like, I don't know, I highly recommend that you do before you look at the answers, because then you can actually learn in that moment. And even though usually, like, I don't know, you're short on time, right? Which is why sometimes you do your homework the night before a quiz. But that's why we have quizzes, so that we could have checkpoints. Just like Cruisin' USA, that game I played back when I was young. Checkpoint. So that's helpful, because then you like look at the answer and you're like, oh shoot, okay, I didn't think about that. That's an open hole or a closed hole. And these are the types of functions that we'll be looking at usually with limits, because it just helps you verify that you know what's going on between one-sided and two-sided. So that was question 15. So, how are you? We got 7 minutes left. Kind of reminds me back in the pandemic days. Sorry for saying that word. But, you know, those video chats, and you got your teacher lecturing, and you have students on the other side. Hello, hello. Yes, things are going well. Thanks. The motto in the house. Amazing. It's just my cat eating food. But, you know, on a video, chatting. It'd be better if I could see your faces, but it's nice to see your words too. So, my goal, 2A number 15, yes. My goal is to keep these chats going, okay? And the idea is I want to do it on kind of different days. Let me know what you think about this statement right here. This is the first one I decided to do because it's the first week getting back into the swing of things. So we're going to topic 2, number 15. Oh, snap. Yeah, that's a good one. And yeah, you're welcome. Yeah. And so the idea is doing it like, I don't know, maybe once a week, but thinking about changing the day. So like today's Thursday, then next week do it on like Wednesday, and then the following week do it on like a Tuesday. But I think this is a good time. I think 4:30 to 5:30 is a good time. So, you got thoughts about that? And then it's available on demand. I'll throw it in like a playlist and just have like random live chats available. And then eventually I'll do some screencasting live, so you could just see almost like a video me doing that. So, topic 2. Number 15, we have this crazy trig function. And I think what's kind of funny is like, as a student in a class before calculus, you don't really know what's coming. So you don't know sometimes when to lean in into certain things in pre-calc, advanced algebra 2, whatever. And so when it comes back, like, oh, that's the thing, I should have like asked more questions about that or whatever. So we have this function. And when I first look at this, I'm like, I'm kind of glad this is 4x and 4x. Otherwise, I have no idea what to do. I might just have to plug in some numbers. So, so here's the thing about this. As far as this goes, as it concerns a quiz, the first quiz, this is officially not in lesson 2A. This is lesson 2B. So I'm going to show you how to do it, and it relates back to just stuff that you did in trigonometry and in polynomials and stuff, and you'll be able to do it. And if it doesn't show up in the quiz, that's fine, but if it is in the quiz in some capacity, then you will be the one to complain. So the first thing I'll say is that tangent 4x is the same as sine 4x over cosine 4x divided by sine 4x. And I guess I'll do this in purple. So this is a true statement based on trigonometric identity, specifically the quotient identity. Well, if you are dividing fractions, then you can multiply by the reciprocal, so sine 4x in the denominator ends up being in the denominator of the fraction in the numerator. That doesn't sound like it made sense, even though it makes sense to me. So you get that statement. And this is basically work that is essentially required for this question. Even though it doesn't say like no calculator, you still can probably just check it out in the calculator. But it's a good practice to just work through this algebraically. So vertical asymptote basically happens when the denominator is equal to 0, generally speaking. So that's when cosine 4x is equal to 0. And that's a little tricky to actually figure out. But so that's the statement we're trying to find out the x value for, cosine 4x equals 0. So that's the algebraic piece right there. Then if we're going to actually sketch cosine 4x, which is what I would recommend, that means the period is equal to 2 pi divided by the coefficient of x. Boom. The question now is like, what does that actually tell us? And what that tells us is that the whole cosine curve starts and ends between 0 and pi over 2. So last few minutes here, check it out. This is it. Here's the curve. So if the period is pi over 2, that means right in the middle is pi over 4. But what we really care about are these zeros. So this is pi over 8 and 3 pi over 8. And that's why in answer choice D has a pi over 8 in it. So pi over 8, and then every other pi over 8. So this is 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8. So basically, odd pi over 8s? What the what? So yeah, that's kind of annoying, but it's a good challenge. So basically the zeros of cosine 4x are odd pi over 8s. 1 pi over 8, 3 pi over 8, 5 pi over 8, and so on. And all of the negatives too, plus or minus, plus or minus. Whew. Boom. Yeah. I remember doing questions like these like occasionally. Like every time we do a trig thing, one pops up like every once in a while. And in a way there's like not enough, but in a way you don't really want more of these because they're just time consuming. So you could write your answer as plus or minus pi over 8, 3 pi over 8, 5 pi over 8, 7 pi over 8, but then you could use a letter like k or n to represent those coefficients of pi over 8. And so usually we wouldn't write it like this answer choice D, so I'll just write what it says. We would just say k pi over 8 such that k is an odd integer. Simple. But since we're here in the 2020s, everything's difficult. So how's that? X equals pi over 8 plus n pi over 4. And then it's this very last part is saying that n is a subset of the integers. That's it. Wow, 4 thumbs up. That was very nice. So that's it for today. Is there a way, would you say, that if you have questions otherwise that you could contact me? So if you have my email, you're welcome to send a message. But there are some videos that you can't comment on. But if you have a question, just ask it through there, even if it's not specifically related to something in the video, or like you could say a certain question number or whatever. And or yeah, Instagram, Facebook, all that stuff. Okay, then finally, I'm trying to hit 200 subscribers, just like my next goal. So if you haven't subscribed, just smash that button. Go ahead, smash it. Okay, peeps. Thanks for joining me, whether you're distracted right now or not. Hope this helped, which I think it sounds like it does. It did. I have lots of great notes about it too. So watch it again if you want. Share it with a friend if you think it might help. If they're at another school or some school in pre-calc calculus. And see you later.